This is Dr. M. Mamala, working as assistant professor in Sri Padmavati Mahila Viswavidyalayam, Tirupati. Today I am going to present my topic on structure of certain classes of semirings and ordered semirings. My RC number is 1531. What do we mean by semiring? The concept of semiring was first introduced by Vandiver in the year 1934. However, the developments of semiring have been taking place since 1950. As we know that the semiring structure abound around in the mathematical world, which is nothing but a natural number set. Semiring is also applicable in different branches of mathematics such as topology, graph theory, Euclidean geometry, ring theory, non-commutative and commutative algebra, quantum physics, and so on. Other applications of semiring is it was mainly applicable to the branch of computer science, optimization theory, automata theory, and formal language theory. And it is also useful for transportation problems, assignment problems, and eigenvalue problems. What is the main definition of semiring? Before we go to see the definition of a semiring, we have to see the definition of a semigroup. A non-empty set S with binary operation dot is associative, then we can say that the group S is a semigroup with respect to multiplication. Examples are any group and a natural number set n and a set with the two elements A and B is also a semigroup. Now we see the definition of a partial order. What do we mean by a partial order relation? A semigroup with binary operation dot with a relation less than or equal to on a non-empty set S, satisfying reflexivity, antisymmetry, transitivity, and compatibility is known as a partial ordered set. Now we see the definition of a totally ordered set. A partial ordered semigroup in which any two elements are comparable, then it is known as a totally ordered semigroup. Now we see the main definition of our topic, which is nothing but a semiring. A triple nothing but S plus dot is a semiring which is closed and associative under two different binary operations with usual addition and multiplication satisfying the distributive laws is known as a semiring. The set of natural numbers with usual addition and multiplication is an example, and any ring is also a semiring. What do we mean by a totally ordered semiring? A semiring is said to be totally ordered if there exists a partial order relation on non-empty set S such that the additive semigroup and multiplicative semigroup both should be a totally ordered semigroups. The definitions which we have seen up to now and which we are going to see are useful for the results of a semiring. A band, semilattice, rectangular band with respect to addition and multiplication. And the definition of multiplicatively subidempotent Viterbi semiring. All these are used in the next sections of our topic. And similarly, a singular semigroup with respect to addition and multiplication is also used, and also integral multiple property. A semiring is said to satisfy IMP if A square equal to NA, where N is a positive integer. Here some of definitions such as E inverse, quasi-commutative, periodic are also given, and a zero square semiring, it is nothing but a semiring S with multiplicative 0 is called zero square, and a partially ordered Positively totally ordered and negatively totally ordered definitions are also given here. And we see the second section, nothing but some classes of idempotent semiring. These idempotent semirings are mainly useful for clean algebras and which are the fundamental structures in computer science with widespread applications. Roughly, idempotent semirings are rings without subtraction and with idempotent addition. And it also useful for diodes, Floyd Warshall algorithm for finding shortest paths. In all these different branches we use idempotent semirings. Here a semiring PRT was given if and only if yes, a multiplicative semigroup is an abelian group. And we see the first result, our first theorem of our multiplicatively subidempotent semiring. As we consider the multiplicatively subidempotent semiring, that is, a semiring satisfies the property a plus a square equal to a for all a in a non-empty set S with additive and multiplicative identity E. Then we can say that S is an idempotent semiring and S plus is also commutative if S dot is a left cancellation, that is a non-empty set S with multiplicative semigroup with multiplicative with binary operation dot satisfies a left cancellation. Then only we can prove the result additive commutativity. And we have given an example with respect to addition and multiplication by considering two elements A and B. Similarly, again we have considered a multiplicative subidempotent semiring and a positive rational domain. Then we have proved that S plus is a band, one is additive rectangular band, and also B plus NAB is equal to NAB. And here left regular and right regular definitions are given for a semi group S dot. And also we have given some of the result by combining multiplicatively subidempotent and monosemiring. We obtain different outputs by clubbing these two semi-rings. And here we apply the totally ordered relation on multiplicatively subidempotent. Then we obtain two different outcomes by considering a totally ordered multiplicative semi-ring with respect to S plus PTO and S dot additionally applying cancellation law. And here next we generalize the concept of multiplicatively subidempotent to idempotent semi-ring, and we have given some definitions weakly separative, and we have given some results by considering an idempotent semi-ring. Then we proved that S plus additive and multiplicative semigroups are weakly separative, and different outcomes are also given in second theorem. As we see the next section, classes of totally ordered idempotent semiring. We applied a totally ordered relation on idempotent semiring, and we have considered S plus and S dot P2. We obtained different outcomes. In the next section, we see the classes of absorption semiring, a different semiring from multiplicatively subidempotent, idempotent, and now it is absorption semiring. The inequality A plus AB equal to A for all AB in a non-empty set S is known as an absorption semiring. Here we have considered first result as we apply S dot left singularity on absorption semiring, and we proved that S plus is a band. Similarly, we have considered A semiring with a multiplicative identity 1, which is an absorption semiring, and we have given some examples for this proposition, and some of the result of absorption semiring with E inverse semigroup is also given here. And a absorption semiring with multiplicative identity and additive identity, we have given some of the results and we framed some of the examples for this one. And a zero sum free semiring is also used in absorption semiring. Totally ordered absorption semiring with S plus PTO is also given, and we obtain different outcomes. If we apply S plus, then we obtain S dot. Similarly, regular semigroups, which are very useful to the computer science people. Structures of regular semirings are also given. A semiring is said to be right regular if it satisfies the identity A plus BA plus A equal to A. And some lemma and propositions are given by applying different constraints on right regular semiring. We have also taken a right regular semiring with additive and multiplicative identity and framed an example and proved that it becomes a Viterbi semiring and a idempotent semiring, and the additive semigroup becomes a rectangular band, and we imposed totally ordered in the next section of right regularity, and we applied S plus PTO on totally ordered right regular semiring, and we obtained different outcomes. In next section, we come across completely regular semigroup. A semigroup is said to be completely regular if S plus is regular and commutative. And we have given some of the results here. We applied PRD and S plus completely regular semigroup and obtained infinitely completely regular elements, and we combined complemented semiring and S plus completely regular, and we obtained different outcomes and so on. Here also we can see a left regular semiring, which is nothing but A plus B plus A is equal to A plus B. We obtain different outcomes for this semiring. As we come to the last section, complemented semirings, which play a vital role in the constructions of frames of computer science in the semantic representations of computer programs and so on. A semiring is said to be complemented if the sum of two elements A plus B is equal to 1 and the product of AB and BA should be equal to 0. And we have given different results on complemented semiring, and by applying different constraints on a complemented semiring, we obtain different outcomes. Similarly, we come across unit semiring. A semiring is said to be unit if the product of two elements AB and BA should be equal to 1, and some of the definition of permutability is given, and we proved some results by applying different conditions on unit semiring as given in this slide. Now we imposed totally ordered unit semiring by considering S dot PTO, and we obtain the maximum element as 1. And in other result, we have given a totally ordered monosemiring with unit semiring and S dot is PTO. Then we obtain the additive semigroup S plus is positively totally ordered. Thus, we come across the different semirings like multiplicative subidempotent, idempotent, absorption, regular semirings, complemented and unit semirings. These semirings have different applications to cryptography. In our daily life, we are using all these, like for drawing amount from ATM by using pin code, and so on. By you to operate the locker in a bank, we use this semi-ring techniques. I thank for giving me this